talk. And also I'm feeling immensely, it's immense joy for me to actually come here, and it's an honor to give a talk to you. When I was coming here, so I was thinking, technical talk to give lagibo. But I think I'll just frank in the beginning that this is not my area of research, the power, right? But my area is basically working in machine learning, deep learning, computer vision, and in general AI. But in last couple of days, when actually I was asked to come here and give a talk, so I browsed through some of the research works that has been done, and how actually they are applying some machine learning and AI into the topics. So I will first give you just brief kind of idea of machine learning. Machine learning ki hoy in the beginning, and how it is connected to AI or data science. And then I will try to give an idea of those research papers that I have looked into, and hopefully that will kind of give you an idea how actually ML and data science can be applied in some of the research areas. So pardon me if I'm using some of the terms wrong when actually discussing about power-related stuff, but I hope I will be able to convey most of the information that I'm trying to in terms of applying machine learning into some of the application areas, like how we're going to show you. So first, what is machine learning? Machine learning here. So we have all, I was also sitting here listening to some of the very good ideas that some of you are actually presenting. So some of the words that was very common was big data, right? Because so you are creating so much data. You have 75 lakhs of customers, I think, and you have kind of installed smart meters, and so many new things are coming in. Smart grid is coming in, and they're collecting an unprecedented amount of data. So they are actually causing this big data phenomenon, right? It's how to deal with them. So data is not useful if you just keep collecting them and storing somewhere. So you have to process it and get some insight out of it, right? So machine learning and AI, so they are coming to automatically detect some insights out of the data. And that data can be, those insights can help us to understand about what is going on, or to make some decisions. So I mean, if a decision then this data can help us, right? Machine learning, there are a lot of kind of words you might be hearing, and some of you may be thinking that they are kind of almost same, like machine learning, AI, data science. What is the common things among them? What are the things that are different, right? That is very important for us to understand. So when we talk about AI and machine learning and deep learning, all those words we have been hearing. So when we look at this diagram, it basically gives you an idea of what it is. AI it is a kind of a superset where we have the general intelligence, where we say that, okay, now how our human brain works, similarly there's a computational kind of model that will allow us to do some stuff just like we humans do, and in fact sometimes better. So machine learning is a subset of it, where actually we are using the data. So machine learning, since we are collecting a lot of data, can we learn something? Can we actually learn some mathematical model using the data, and that can be useful for some decision making, right? And finally we have deep learning, which is maybe you're hearing. So it is one of the categories of machine learning algorithms that are getting popular because deep learning can utilize a large amount of data. Traditional machine learning models, they are just using some mathematical models, use some data, but they are not good if we have large amount of data, right? So that's why deep learning is coming into picture, where they are utilizing a large amount of data. They can use that, and also you might have hearing the GPU GPU bilak ami computer basically thake. Mostly a lot of you may be using for gaming, but those GPUs can also be used for machine learning purposes, in particular for deep learning, where they can do some parallel processing. So it's not like that you have a CPU apni eta program cholai ase, then again you wait for 1 hour, again do something else. GPUs let you run it's like multiple CPUs running in parallel. So GPUs are coming in, they are getting cheaper. So GPU, this GPU technology is coming in, plus a lot of data coming in. This together, these deep learning algorithms are able to utilize both of these two things, and then giving us unprecedented precision, accuracy in some of the models. Those traditional machine learning models were not able to do. Okay, so that's why deep learning is getting traction. But a lot of the things, you make a mistake that, okay, if someone is working in machine learning, maybe many of you are working, so key hoy je ami jetia we want to solve some problem, we say let's use deep learning. So that is not the thing. So ami sabo lagibo je if something can be done in a simpler machine learning model, ami hetu use korim. But if we find out that we have lot of data, we have lot of resources, and you have a big data, then most probably deep learning models can also be useful, but it's not necessary. But in general, what is important is the machine learning part. That was mostly these days people are using. So if we read a paper or someone is giving talk, even the 2 talks that we heard, they are mostly talking about machine learning. Right? So machine learning has 3 different kinds of paradigms. One is supervised learning. So supervised learning is key. So you have data, our data, you have some input features, and using these input features, we are trying to predict something. So you also have a corresponding label. For example, if you have a bunch of pictures, there are only dogs and cats. So the key hobo, say someone will annotate the images, they will take say n number of pictures, or kobo je ekhon image dog image, this is dog image, ekhon dog image, ekhon cat image, and so on. So you have the input images and also at the same time the labels. Mane ekhon input image ki bujabo bicharise, but what kind of information is there, right? So these are labeled information. So jetia ami tenuka data use koru jot apunar data khini ase plus eta label do ase, hoyto these labels are coming from some manually someone annotating it, right? So then we can use these learning methods called supervised learning. So unsupervised learning is a different kind of paradigm jot amar label nai, but just looking at the data we can say that okay, these images looks like these images belong to some one particular class, these images belong to particular one class, karon ami hoyto algorithm ke sabo je what are there in the image, right? Maybe there's some corner edge based on that they will decide that okay, this looks similar, this group looks similar, this group looks similar. So you might have heard some kind of algorithms like clustering algorithms. So clustering, what they do, they cluster similar categories of objects. So our label 9, but still we are able to find some insight. Okay, there are this many groups, similar groups in the whole data, right? Reinforcement learning is a different category which may not be right away applicable in your area, but this is something like we learn from our actions. So we perform an action in an environment, then we find out okay, after performing this action we are getting this result. Now this result is favorable for us or not, we find it out. So if it is favorable, then we keep doing it. If it's not, then we take a different action to find out what will make our action more favorable. So in that case, we're learning in the environment dynamically. So typically, most probably if you're working in this area, and by default, most probably you are using some supervised learning and unsupervised learning, right? Kintu eta kotha we have to keep in mind that supervised learning, although it is a very popular one, but data is always a problem because you need a label. So someone has to collect the data at the same time, they have to label it. Okay? So if we talk about these first two categories of learning, so supervised learning, we have a data set, we have some example labels. Okay, dia ase je A2 data sample at amar A2 label hoy. Say for example, you are reading some smart meter readings and from some customer, and you are saying that okay, they may be doing some there may be some theft. So then you find out and then you label it that there's a theft data or this is not. So those kind of labels are there. So there's a machine learning model. They will learn during the training jiman bilak data we have. So we will take the data and we will learn from it. And then after that, this model will be able to predict okay, amar jodi ekhini data ahi ase this kind of features, what will be the category. For example, in the first example, I said we have some images, we have to find out that picture has a cat or a dog. So the key about in this case, we learn the model and then we give the image as the input, and the model will tell you that whether it's a dog or cat. Right? So that happens during the inference. So training is a different process, inference is a different process. Training I learn model to, and inference model to apna now we can maybe in real time can tell you an image dim and you tell what is a dog, a cat or dog. And this is applicable to all kind of problems. For example, if in your case you are trying to predict say what is the current load or something, right? So in that case you have some features you give to the model, and using the existing data you can train it, and after training you can use the model kiman load hobo. If you give the features, it will model pe kobo je kiman what is the load, right? Unsupervised one is a bit different. That apnar jehetu kono label nai, so the model will just learn kiman category ase, kiman group ase, and give us some idea. So that is the whole idea. Hoyto you will see that okay, for example, at the example jodi moi diu, you have some data, for example, coming from smart meters, for example, and you will see that some kind of activities are going on. In some of them are really different than what regularly they are. So in that case, that model will tell, there is a category of data which is very different from general data. So in that case, it has some idea, okay, there are some outliers, some kind of things are going on. So that information you are getting from that particular data, right? So again, I talked about this particular Venn diagram where you have an AI, you have a machine learning, you have deep learning. So deep learning is actually a part of a category of problems called ANN. Okay, so artificial neural net is also actually a superset of deep learning, but it is part of a machine learning also. So this is a special kind of model. I just wanted to mention because there are two kinds of machine learning models. One is classical model, and one is artificial neural net based model. So artificial neural net based models are a bit different because they kind of mimic how our human brain works. So they have different kind of layers, they have different kind of components called neurons, and they learn during training that how actually how human brain works. It kind of tries to mimic that and learn better. So currently most of the, in particular in computer vision, which I work in, so heteroarea mostly if someone is getting the best result, for example, someone is trying to use someone is working on a driverless car and that car is going around in the lane. So it has to find out if there's a pedestrian, someone is crossing the road, there's a tree, there's a sky, So all this information typically, they are using some machine learning models of course, but most probably they are using some artificial neural net based methods because these particular models, in particular deep learning, is giving us the best results so far. Because the traditional machine learning we're giving, say for example, in a particular example data set, 76% accuracy. Now this deep neural net based are giving us 90% accuracy. That's why there's a big AI and deep learning people are, there's this hype going on. It's not necessarily hype, but some people are, what they're doing there, when they say AI, most probably actually they are talking about these deep neural net based models. So what they do, they basically, typically if you have some data, something like this, it is very difficult to separate out where there is a dog, where there is a cat, right? There's a blue dog, there's a black cat, red cat, it's very hard to separate out. So what these complicated models like this artificial neural net, in particular deep learning does is that they transform the input data to another data kind of representation where it is very easy to separate them out. And that's why these neural nets are working very well, because they have some kind of components that will transform this particular space to this space. Up to this side, then this is very easy now to separate. You can just draw a few lines and then you can categorize. So internally during the computation, during the modeling of it, so this thing actually happens. So that's why if you see some ANN, CNN, transformers, these kind of models are coming in, they basically are very good at transforming this space to this space. But traditional ones are not very good. That's why whenever now people are talking about ML, AI, most probably they are talking about some deep learning, but of course some traditional machine learning are still used because in some cases you really don't need such a complex thing, because if your data itself is simple, why should you go for some complex model? In that case you can use some simple machine learning model and get done with that, right? So now you're talking about, when you talk about big data, it's a bit different because now all this, because I'm from a research background, so when I do some research, typically we do with some small data, not big data. But when the people like you, when you're actually on the ground and doing all this, collecting data, having this kind of smart meters and all those things, you're collecting huge amount of data. There's a big gap. So when you do research, we do small data, but when you are doing it, you have to deal with big data. So now big data is a bit, then the kind of software tools that we are using in our research will be a bit different in big data, right? But some of the properties of big data, why they are different from our, research data? Because first of all, of course, the volume. So it's a large amount, huge amount of data. Velocity, because data is coming in and maybe it's very important for you that you perform this in real time. You cannot wait for the whole day to run a program and then get the result. You might have to do it in nanoseconds. Who knows, right? So it depends. So in that case, how actually we can handle this big amount of data, perform some computation on that big data where it's maybe stored in different data, data lakes or some databases, and you have to collect all of them together, then do some computation, do it in real time, and finally this data has a lot of variety, could be, right? Maybe some data is like, some text data, some data is some video data, some is image data, and some is some speech. I don't know, I mean, maybe not in your case, but in general we also deal with a lot of different kinds of data. How actually we can extract features from all different kind of data, combine them together, and then you can use some machine learning model to perform some kind of computation and take some decision making. Yeah. So that's a big challenge. Sorry. Okay, so now there are a lot of different software tools are there based on what you are trying to do. So you have a big data, for example, what kind of database you can use. Many of them you may be using it. What kind of software I should use for processing the data, filtering the data, pre-processing the data, cleaning the data, storing the data, messaging system. All those things are very different if you actually go and kind of try to employ them in a real big data, right? In your case, if you have 75 lakhs users, then you have to think this kind of scenarios where you have a huge amount of data. So it's not like that many users. They are creating data every second, maybe every 15 minutes, maybe, right? Then you have all the data collecting, and it will not become some 1 gigs of data. It will become petabytes. In that case, your whole scenario will be very different. The software you are going to try to use are very different, right? So as I said, again, for research debugging, we use usually small subset because when you are working in a lab, we don't want to deal with all this big data all the time. We want to implement some on a small data. We kind of test it, we debug it, and then we kind of now once this data set is kind of we implement something for the small data set, and then we go for implementing the big data if needed, right? So we usually don't deal with all this software all the time. These are typically when you are going for implementation level. Typically what happens in the workflow, we should always think about what is the problem. It's not that I just want to use machine learning. So that should not be the motivation. Even it's a very tempting thing, right? Everyone is doing machine learning. I also want to do machine learning. I also big data. No, it comes from the problem. What you are trying to solve. If the problem requires a simple linear model, like we saw some weight-based model in the second last talk, maybe that is good enough. There's no point maybe using some ANN or DNN, all those kind of things. But maybe it's required. So depending on the problem, you have a lot of data, maybe you can go for ANN and all those kind of complicated models, right? So formulate your question first. And in that part, you require some domain knowledge. So you are the right person because you are dealing with the data all the time. You know what are the challenges. You are dealing with customers. You are dealing with collecting areas, and all those things are there. So you know the real problem. If I go there without having some knowledge about it and I just want to implement it looking at some data, that's not a great idea. So typically that's why when you are implementing this kind of project, you need a big team where there are people from different backgrounds. Someone knows about a domain, right? You know about how things work. Someone maybe is good at coding. He knows how to program this kind of machine learning models. Some are experts maybe in big data. He have dealt with some really big data somewhere. So this team comes together. They come together and then they solve the problem. So that's where a real good data science team comes forward to solve this problem. So then once you have this idea that what is your problem, then you collect some data, right? You may have some data there, but ultimately if you don't have, then you go forward and collect it. Then you think about how to store it. And once you store it, then if it is a big data, then there are some softwares I have already shown. Using those software, you can access the data. And then you do some plotting, look at the trend, what is going on. For example, if you're looking for the consumption of power, then you can see, okay, maybe during summer it's more, during winter it's less, so those kind of patterns you can see. So those patterns you can see when you actually sit there, load the data, plot the data, look at the features, how these features are related to the consumption, and all those things, correlations you can do, and then you can decide on, okay, now I think as a domain expert, as a software programmer together, we think this is what's happening. And once we know that, then it's very easy for us to pick what kind of model we have to use, what kind of complexity is required, right? And once we had that, then we train the model, get the decision. Once we're happy with the accuracy of the model, then we create a report, visualization, we share with other stakeholders, and they also say they like it, okay, this is great. Actually, we tried it in different pilot projects and this, and I found out that. Then you finally, if you're happy with the result, then you go and implement it. And then again, you don't just implement it for the full scale. You apply it in a small scale and see the results. You may find out some insight that, okay, maybe this thing might have to change a bit. Then you can go forward, change it, and then again, iterate this whole thing. So you have to keep asking, and you have to do it in several iterations. So that's the whole idea. Again, this thing I said in the beginning, this is not my area of research, but I exposed some work, and maybe I will try to show them how actually, what are typical process they could be, so that you can apply. There are different applications. Some of you have during the previous talks already mentioned. There are a lot of different things that happen. electricity theft you can find out, maybe predictive maintenance, you'll know better. Customer behavior, system monitoring could be important for us in that particular data set. Okay? So that is one example. The second example is how can you detect some theft? That could be one example. Where this is important because it can affect it can happen different ways. There could be cyber hack, there could be some physically actually something bypassing the smart meter or doing some tampering. All these things can happen. And so this is some stats that I got that in India maybe there's like around 2015 there's $16.2 billion of loss. So I just got it from that paper. We have to verify that. So it's a big amount that is being lost. So what I'm mentioning here is that this is not something that happens only in India, it happens everywhere. So they are dealing with it, they are solving it using some technique, some AI, so why not we use it here? So that's my point. So this is the typical machine learning workflow. Again, I don't know whether you can see it from here, there or not. So same thing, they have some data, they are doing some pre-processing. Okay, also looking at the data by plotting them, visualizing them, what is the pattern out there. And then they pick a model, they train it, test it, and then finally using the model they are predicting it. And also they have some metrics that tell you that whether your model was accurate or not. Okay. So finally this is some data set that I saw, I got it, why basically it's from Ireland. They collected some data. So what they did is they picked 5,000 residential households and businesses. And they collected the data, and they also had some other features from those households. They also, and for them, one thing that was difficult was to actually collect some malicious data, because there they found it's pretty rare. But what they did is they actually synthetically created some data, which is kind of a pattern of a kind of theft. So they actually synthesize some data, right? And then in this case, again, they're using some supervised thing, because they have the data and they have some labels, whether it is a benign data or malicious data. Okay, so they have two labels. So you can still use some supervised machine learning algorithms to solve this problem. So in the beginning, again, they look at the data, what happens, what kind of patterns are there. When there are different seasons, different types of users, different days of the week, or maybe the year, is there any events, right? So based on the lifestyle, seasons, weather, and all those things, these are the factors that determine what kind of consumption is happening. Okay. So for example, this is something they plotted that, for example, if seasons changes in spring, autumn, summer, winter, the behavior will not be same like here. Of course, Ireland, if you go see, it's a very cold country. That they use a lot of heaters during the winter. We don't use heaters. So that is you'll see actually that pattern that okay, there might be actually spike in the winter than the summer because of the use of the heaters. So that you will not see here. So those things are very interesting when you actually look at the data. So it's not that you can directly use some data from Ireland and use it here. So be very careful. So we have to collect our own data and use it for modeling. So that is very important for us. Okay. So actually when you look at the data, you get a lot of insights where what's happening in the spring, what is in summer and autumn. So that can give you some information. Type of users, right? Is it business use, residential use? They also make a lot of difference. Of course, maybe in the business use, the use is more. And those things you'll see. Day of the week, Monday, Tuesday, Wednesday, Thursday, and Friday. Maybe you're staying more at home. Maybe people are trying to use more electricity when it's not a peak hour, because peak hour is costly. Also, if you see in this particular data set, if there's a Christmas, New Year, there's a sudden spike. So all these things you can see from the data. Pre-processing, once you actually have an idea about the data, what is going on, that part is very important. You do that first. And then you do all this, again, the same pre-processing part. You clean the data, missing value, you kind of replace and find it out. And then you kind of, if your data have different features and their range is very different, then you try to put in the same range. There's one of the talks, I think the second class also mentioned about that. Normalization of the data is very important because some of the machine learning models will not work if they don't come into the same range. Because in that case, there will be a bias. Maybe one of the feature values is very high, one is very low, then the higher value feature might influence more than the lower value. So why should we do that? So that's why we normalize it to some, maybe range from 0 to 1. That's one example. Then we actually divide the data set into train, validation, and test. This is very kind of technical part where we do it because we don't use the whole data to train, because we train on a subset of data and test on a different data. Because if we train on the same data and test on the same data, you will get the best performance. But that's not the goal. Our goal is that I will try and learn the model in some data and test in something what I haven't seen. That's the goal. Because tomorrow the data I'm collecting may be a bit different, but will my model work on that data also? That's why during the training only, we divide the data set into several parts and train on one set and test on one set. So then we get a more generalized model that is generalizable. And also data balancing is one important thing, because say you have a data set where you are saying that this data is related to the theft and this is related to the normal situation. So if you have a lot of data from normal data, but very few data from the theft examples, then your model will not learn that well. So what you have to do, you have to balance. So that's one of the goals, is that you try to find out that both the classes have a similar number of data. So those things are done typically when you pre-process the data before training. And then in this case, actually they are using a CNN model. It's a part of a deep neural net. Again, they found out maybe they have applied different kind of architectures, simple machine learning models, complex machine learning models, and they found out that this model was working best for them. So I will not go how it works, because I don't have time to explain that. And finally, they compare the performances. Like for example, CNN, it's a convolutional neural net. They tried simple models like support vector machines, random forests, decision trees, and all these things. That different machine learning models are there. Some are deep, some are not. But ultimately they compare all of them and they find out that this particular works best for them. So this is how it was. So this is again, sorry, I cannot see it. But what I'm trying to say here is that there are hundreds of applications in the, for example, smart grid they are showing. So I think there are a lot of opportunities that are there. So I think a lot of other countries around the world are using it, using AI and machine learning. I think it's also right time for us to actually go ahead and do something. And I'm very happy to see that some of you have already started working along that direction. So it's great. They should not just remain in the academia, in the labs. They should come out and help people in some positive way. Challenges, data, when you're using data, you have to be careful. Some of the things that I already mentioned, sometimes the data is not complete, so you have to fill it up. There are some assumptions are required, some domain expertise are required. And sometimes, again, the second point is that data can be of different types, heterogeneous. So how can you actually combine them together into the same kind of reference? And then also you're collecting data at different rates. Some are fast, real time, some are not. How actually kind of going to deal with all those things? So those challenges will always be there, but there's ways to solve it also. But there's no like one silver bullet and there you can solve all the problems. You have to look at the data, you have to sit, you have to breathe with the data and then spend time, look at the pattern, what's going on, and then only you can decide on what kind of algorithms or models will be appropriate for that. Risk, of course, there are privacy information and information security issues. So because you are using data from the customers, and then actually you are seeing the patterns from the users, but users may not like that, right? Because you are learning the patterns, how they use the electricity. So you have to make sure that you have some consent from them in some way, because you just go and grab the data, they may not like it, or maybe actually they can sue you in some way. So you have to very carefully take the proper consent. Okay? And cyber attack can happen because now these are available online, you can access them. So someone have some malicious behavior and someone malicious way they can attack it, and then maybe they modify some data. So you have to also make sure that when you are using the data, make sure that those are not hacked data or something, right? You have to make sure that these are proper raw data and not affected by something like cyber attack. And how to deal with that? One is I already mentioned notice and consent process are required because ethical issues are also there when you're using data. Right? You're using data, but are you allowed to use the data? Because if my Facebook information, what I post in Facebook, what is in my phone, that is also data, right? And someone will say, I want to use all the data to do something. But no, I don't want to give you the data. So I have to take my consent before I give you the data. So that is very important. And also, if possible, you can use the data. If I give you a consent that yes, you can use the data, but you have to remove my name from the data. There should not be no linkage that this data was associated with me. So those kind of things are also there, right? Because so that will make sure that you are using the data, but you are not pointing to someone. Someone cannot in future point out, okay, this person was doing this particular activity. So those things you have to also take care of when you're using data. It's not just that you collect the data and do something. You have to take care of all the different aspects of it. That's why you need a good team where you have people from, not only just from programming background. You need people from domain experts, people who have worked in this area. They understand on the ground what happens, what kind of challenges might happen. So that's a proper team you might be looking for when you're trying to build a big database system. So that's it. So thank you again for giving me, for letting me come here and then giving this talk. And I hope it was useful. Thank you. you.